Understanding speed through line graphs. Imagine a car moving smoothly on an open road, then slowing down in traffic and speeding up again. Have you ever wondered, how can we show all those changes on a single graph? That's exactly what we'll explore today. Before we start, if you've watched my previous video, you already know what speed, average speed, uniform motion, and non-uniform motion mean. If not, don't worry. You can always check it out later for a quick recap. Now, let's take a closer look at the real difference between speed and average speed, and then see how line graphs help us visualize motion. Average speed gives us an overall picture of how fast an object moves during the entire journey. It's found by dividing the total distance covered by the total time taken. For example, if a car travels 60 kilometers in 1 hour, its average speed is 60 kilometers per hour. But does that mean the car was always moving at 60? Not really. In reality, the car might move faster on an empty road and slower in traffic. If we want to know how the speed changes at different points, or get a clearer picture of the entire journey, we would need to collect a lot of data, the speed at many different times. Now, imagine recording the car's speed every few seconds. We'd get a long list of numbers. So much data. It would take forever to understand what's really happening. So, what's the solution? We use graphs, a simple and powerful way to visualize all that data. There are many types of graphs: bar graphs, pie charts, and line graphs. But for studying motion, we mostly use a line graph because it shows how distance or speed changes with time. Just by looking at it, you can tell whether an object is speeding up, slowing down, or standing still. So, let's learn how to read and draw one. We'll begin with uniform motion, when an object covers equal distances in equal intervals of time. To understand this better, let's draw a line graph for uniform motion. Here's the data we'll use. Time is given in minutes, and distance is given in kilometers. Draw two axes, the x-axis for time in minutes, and the y-axis for distance in kilometers. Now plot these points: 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Then join them with a smooth, straight line. A straight line means the object moves with constant speed. That's uniform motion. Now, what if the object stops for a while? Let's see what that looks like. At first, the car moves uniformly. Distance increases. But between 2 and 4 minutes, the line becomes horizontal, showing that the distance doesn't change. That means the car is at rest. When the line rises again, motion has resumed. A horizontal line on a distance time graph means no movement. Non-uniform motion. Here, the object covers unequal distances in equal intervals of time. When you plot these points and join them, you'll get a curved or uneven line. This shows that the object's speed keeps changing, sometimes faster, sometimes slower. That's non-uniform motion, when speed is not constant. Now that we've seen all three cases, uniform motion, rest, and non-uniform motion, let's explore the last one a little deeper to understand how the speed changes during a journey. Let's look closely at the non-uniform motion graph to understand how the car's speed changes. Now, let's look at the point at 10 seconds and 42 meters. If we divide the total distance by the total time, 42 divided by 10, we get 4.2 meters per second. Now, think about this for a moment. Do you think 4.2 is the speed or the average speed? That's right, it's the average speed of the whole journey because the car's speed kept changing, sometimes faster, sometimes slower in between. To find out how fast the car was moving near 10 seconds, we can look at the small straight line on the graph between the two nearby points, 8 seconds, 40 meters, and 10 seconds, 42 meters. Let's find the distance covered in that time. 42
minus 40 is 2 meters, and the time taken, 10 minus 8, is 2 seconds. Now, when we divide 2 meters by 2 seconds, we get 1 meter per second. This means around 10 seconds, the car was moving quite slowly, only about 1 meter per second. We can repeat this for each small section of the graph to see where the car speeds up and where it slows down. 0 to 2 seconds. Distance increases from 0 to 6 meters in 2 seconds. Speed is 6 divided by 2 equals 3 meters per second. The object starts slowly, maybe just beginning to move. 2 to 4 seconds. Distance increases by 10 meters, 16 minus 6, in 2 seconds. Speed is 10 divided by 2 equals 5 meters per second. The line becomes steeper. The object is accelerating. 4 to 6 seconds. Distance increases by 20 meters, 36 minus 16, in 2 seconds. Speed is 20 divided by 2 equals 10 meters per second. This is the steepest part. The object moves very fast, reaching maximum speed here. 6 to 8 seconds. Distance increases by only 4 meters, 40 minus 36, in 2 seconds. Speed is 4 divided by 2 equals 2 meters per second. The line flattens. The object is slowing down, decelerating. 8 to 10 seconds. Distance increases by only 2 meters, 42 minus 40, in 2 seconds. Speed is 2 divided by 2 equals 1 meter per second. The line is almost flat. The object is barely moving, nearly at rest. Overall graph interpretation. If you plot this data, the curve rises steeply at first, showing increasing speed. Around 4 to 6 seconds, it's steepest, meaning the object is at its highest speed. Then the curve flattens, showing decreasing speed. By 10 seconds, the line is almost flat. The object has nearly stopped. Summary. Let's quickly summarize what we've learned. A straight line equals uniform motion or constant speed. A flat line equals object at rest. A curved line equals non-uniform motion or changing speed. Graphs make it so much easier to understand motion, turning numbers into clear, meaningful patterns.
So you've now learned what average speed and speed are, and how to use a line graph to understand the motion of an object in detail. This forms the base of your understanding, and once this is clear, learning ahead will be even easier and more exciting. Also, in this video, I didn't go step by step into how to choose the scale or draw the graph in detail. If you'd like to learn that next, comment below and let me know. I'll make my next video showing exactly how to draw and label a line graph for motion step by step.